A parcel just arrived from me today. Let's open it up together and see what it is.
It's your mom.
It's like Christmas. My PCBs have arrived after 2 weeks. So we're going to open the box together and see what it's like. Got it there. There. I believe, yeah, I've got to cut it there. Alright, let's open the box. Ooh. Slightly differently packaged to the ones before for that AEL 480 power supply, but yes, these are the PCBs to this 1 watt champ amplifier. I know I didn't actually show this in the PSU video, but that's actual PCB way code. If you wanted to get the PCBs, I'll put a link in the description when I put all the files up there that I need to have up there, like the schematic for one, and some pictures and a link to this video, and then you can go ahead and order the PCBs yourself. So please do not ask me in comments to send you a PCB. Unless you're in Australia, I might be able to send you one, but it probably cost you about $7.50 in postage, plus I'd want probably $5 for the PCB. Just keep that in mind. But it'd be easier to order it from PCBWay directly, because it only cost me $20 AU, I think it was. Maybe a little less, 16 for the 5 of them. And that's the minimum quantity you can order, is 5. So I'll get this bag open, dispose of that. Oh, look at that. They are super sexy looking. It's like a thing of beauty. The Champ Amp. Oh. Soldering these transistors, because of the closeness of the pads to each other, is going to be a real challenging pain in the ass. I shouldn't have made them that close, but that's the underside of the board. It's up to their usual quality. Yeah, looks better than the picture anyway that I showed you from off the site, because yeah, their Gerber to image software is not that great, but it gives you a sort of a representation of what it's going to look like. So, wow, I'm happy. Anyway, over here is our little preamp, Class A preamp, as I said, and that's our boost connector to go to a switch. We've got the 9 volt DC to 12 volt DC inputs here. There's 2 of them, one for a 9 volt battery and one for a DC plug pack, going through this OR circuit made of these 2 silicon diodes. The power off, that goes off to a power switch. That's the speaker out, that's ground out. Input comes over here. There's a little indicator LED to tell you that the circuit is indeed on. And yeah, your pot goes there, and over this side is the actual Champ amplifier with its Class A preamplifier and the 2 output transistors, which are BC327 and BC337 respectively. So it's going to be a good Easter after all. So I'm going to assemble this now. As I said, doing these transistors is going to be awkward because they're awfully close. So I hope their solder mask is good, and after I've soldered them, I'm going to have to check for shorts between the pins. Fun, but that's what it is. I should have used a larger footprint, but I was trying to keep the board as small as possible. So anyway, let's get started on that. Alright, I'm ready to assemble my PCB. I'm going to start with the resistors first, which I've got laid out, written next to it what the values are, so I don't have to bother reading them, because I went and sorted through my, I'm going to call that my junk box over there for all the loose resistors. I found most of them I need. I'm just missing the 8K2 and I'm missing the 330 ohm, but I've got some of them somewhere. I've also got a brand new 1N4148 diode. I did have a loose one knocking about. I don't know where it's gone. Alright, so I'm going to start by assembling the resistors. I'm going to get that part out of the way and come back. I'm not going to take much footage of this. But I need all the space I can get, and the tripod would kind of be in the way. The resistors barely fit in the footprint. It took a lot of effort to get them in there. I'm going to have to remember that on future designs to not use that footprint, use a slightly larger one. Solder mask burns easily. It's really kind of annoying. Didn't solder properly at all. Yeah. Okay, all the resistors are in. I've left the 1 ohm resistors slightly higher than the board so they can generate a bit of heat. It's very tightly packed on here. Got the signal diode in, got the 2 rectifier diodes in, and I've sealed one of my pad holes with C1. That's, yeah, okay, I'll just have to gently heat the lead and push it through. That's okay. Underneath it's holding up pretty well to soldering, so yeah, it's up to their usual standards. Now the fun bit, trying to get the transistors to solder in. It's going to be awfully delicate. I haven't put that resistor in because that just drives the LED, so I think it only needs a 1K there for a plus 9 to 12 volt supply. But I'll put that in later. I'm not really worried about that right now. Yeah, I can get it to solder in there, but Christ, it's close. Yeah, not really happy with the pitch on that at all. But yeah, it is what it is. It's not shorted by the looks of things. I'll test them all after I finish soldering. Okay, transistors are in. It wasn't too painful, but yeah, it's all looking okay. So now I'm just going to move on to capacitors. It's starting to look sexy, almost completely populated. Unfortunately, I've now run out of components. I don't have the variable resistor I need. I don't have any of these connectors, but I'm thinking for what I'm going to be using it for, I'll probably just put hard wires to it rather than connectors. But I don't have a switch for the power, so if you don't have that bridged, well, it's not going to work. I don't have a DC 9 volt jack. I don't have a battery clip lead. I don't have another LED. And I don't have the 470N capacitors or the 470 microfarad capacitors. So apart from those components, oh, and another switch over here. Apart from those components, yeah, well, it's coming on nice and sexily. So I'm going to have to wait till after Easter to go and get my parts because, yeah, I don't have the funds right now to finish this, but I will do. Good thing is, I've now used up the remaining of that solder that was in the kit. There's bugger all left now, so waste not, want not. Speaking of waste, it's always fun when you're assembling something and having a bunch of shit like that lying on your desk to clean up. You know you've accomplished something then. So when this is all finished and assembled, I plan on mounting it in a small jiffy box. hence why I've got two standoffs here. They're nylon. I've got plenty of them, might as well use them. And it's going to spend most of its life living upside down in the Jiffy box, pretty much like that. Oh no, not like that, it's a bit drunk. Pretty much like that, upside down, so all the electrons fall out. And I'll have a board mounted pot, a little 9mm one. The LED will pop out the side of the box, and the input connector can go somewhere. And these two standoffs will be drilled to the back of the box with screws going through it. If that makes perfect sense to everyone. Okay, the little champ amp is built now with all its capacitors on it. I can't remember where exactly I'm up to. This is what happens when you work on multiple projects at the same time. These capacitors are, yeah, well, yeah, just a bit how you're doing. I couldn't get 4 70 nanofarad capacitors, JK. I didn't have any this morning, so I've stuck 680 in there, and they're a lot larger than, yeah. It'll still work, it just looks stupid. Okay, so I'm ready for testing now. So I've got it all hooked up to a dummy load to the oscilloscope. All I need to do now is flip this little switch and see if we get an output. If I so can switch the switch. Whoa, yes we do. Albeit it's square wave. Turn that right down. There we go. I've got way too much input signal going in. It is working though. Yeah, we're easily getting our 6V out, a little less maybe. Got it on the wrong time base. That's better. And it's not. We are seeing something at the negative there, so that's not very pleasant. So it's not quite symmetrical, which is kind of annoying. So I don't know whether that's to do with frequency or... No, it has nothing to do with frequency. So yeah, that's kind of bloody annoying. It didn't do that in the test circuit. So I have no idea what's going on here. Alright, so I'll turn it down. I just don't like the fact that it's clipping on the bottom. I'll turn the boost switch on, and it's even worse. Oh my god, that's going to sound absolutely f***ing terrible. Well, okay, it was only $5 for the PCBs and probably $20 for parts, but yeah, let's hook it up to a speaker and see how it actually sounds. Okay, got the speaker hooked up now. Well, okay. Doesn't sound that terrible, but you can actually hear the clipping. So let me find an audio track. I cannot hear anything coming out the speaker though, so that's good. There's no oscillation. Yeah. That's distorted. Yeah, that's no good at all. That's absolutely no good at all. That was a complete waste of effort. I am disappointed. It appears I've bypassed the volume control. It appears to be the input transistor or input stage doing it, because it's not clipping anymore. So there's something with the input stage is not quite right. I'll have to pull up the schematic to see what the heck it was. Alright, that's a lot better. I've actually fixed the input stage. It was a bit of a prick to do. Over here on the input stage Q1 here, R3 is a 150k. That value is way too high, so I changed it to a 33, and it seemed to fix the problem. So it's 100k and 33k here. Don't know why it worked on the test piece of breadboard properly and doesn't work on the circuit board. I've balanced this BC546 transistor. Good job that I've only marked the silk screen with R1, R2, R3, so it's easy just to change the schematic and it doesn't make it confusing on the PCB. I've just shoved a red LED in the pads here just to see how bright it is. I've chosen a 470 ohm resistor for the dropper, so I might actually kill that light. Ooh, yeah, as we can see, it's lighting up reasonably okay. It's not overly bright. It's a bit dull too, but anyhow. Okay, so I'm going to drop that down, right down the volume on the PCB here, and I'm going to hit the boost switch. Boom. There we go. Isn't that special? So we're getting, on this circuit now, 5.36 volt peak to peak before clipping, so I'll back that right off. So 5.36 divided by 2 equals that, multiplied by itself. What's the power of 2 is that, now divided by 8, our load. 897 watts, not too bad at all. That's quite, it's quite close to the 1 watt, but not quite 1 watt, but it's close enough. So after that little disastrous fail there, it's functioning quite nicely now, and the distortion is not there anymore. So now I'll hook it up to a source of music and we'll do another sound test. Hopefully it sounds a lot better this time. Okay, turn that back on. Turn boost off. Alright, stop that. Go back to this. Turn the speakers of the laptop down. That sounds a bit better. Okay, we get the idea. It sounds okay. There's a bit of noise coming off the computer, but it's, yeah. Alright, so I'm quite happy with that. I will, I forgot that was written on the whiteboard in the background. Yeah, we'll just pretend that we didn't see that, okay? Yes, anyhow, I'm going to leave this video here. It's functioning how it should now. I'll update the schematic and I will make this project available on PCB Way, so you can actually either download the Gerber files or you can actually have the PCB manufactured and assemble it. Just one thing, use smaller footprint capacitors in here, not that large of a capacitor, they don't fit properly. Anyway, that was a success after a fail, so I'm happy. Anyway, I'm the Astro 30. If you enjoyed this video, please remember to rate, comment and subscribe. And you can always follow me on Facebook or become a Patreon member for as little as $1 a month. Anyway, I'm the Astro 30 saying, see ya, have a great day.